Good morning. How's everybody doing? I'm doing well, doing well. Let's see, how many people we got in here? We got a few. Sadie's tired. Yeah, I woke up really tired this morning too. Meredith is good. That's good. I'm glad, Meredith. Glad you're good. 10 out of 10, says Ellie. Nice. Oh, shoot. Did I not update the title? Dang it. I always forget to do it. I do everything else, and then I forget to update the title. Yeah, let me fix that, Lauren. Always forget to do it. Honors chemistry. Homework up. Okay, there you go. Now the stream information should be updated. 3 hours of sleep, Ellie. Good thing we're only doing class every other day. Hey, Jake. That's weird. Huh. Cooper's has an adamant no. 2 hours. Oh my gosh, guys, sleep more. At least sleep in tomorrow. I don't know what your other teachers are doing. Apparently you don't have anything in for geography this week, if you're in the same class as Sadie. Yes, Ellie? Good job, Zach. You do have time for sleep. You literally don't have time for anything else. Like, all you need to do is sit at home, take naps. So you got to remember, Izzy, sleep carries over, right? So today you'll be feeling what happened, the night before. Yeah, I used to sleep, or sorry, I teach a BYU class at night, Slayer. I forgot to update the title, but the title should be updated now. Yeah, Brigham Young University. I'm glad your joggos are awesome, Ellie. Ellie, your message is gonna get really fragmented unless you do it. Yeah, it happened while I was teaching BYU, Sadie. The earthquake was going on like right in the middle of teaching BYU. So it was on my stream last night. Yeah, I don't know, Izzy. Maybe you have a vitamin B deficiency. Yeah, there also is. Yeah, you're right, Slayer. So the time of sleep is one thing, and quality of sleep is another thing. You could be asleep but never actually get into quality REM sleep. But yeah, no. Sorry, Valen. No Valorant drops. Unfortunately. Were you dropping weights? Ooh, tornadoes, Serenius. That's intense. Wait, there were some pretty bad tornadoes in the south. Are you from? Is that where you are? South? I know, like Tennessee, Georgia got hit with a really bad tornado. I grew up in Tennessee, actually. Do bananas have melatonin? Do pineapples have melatonin? I didn't know that there were any natural supplements for melatonin. I thought your body just produced it. Yeah, there was another earthquake last night at like 8 o'clock. Yeah, I'm pretty sure melatonin. Yeah, there are the supplements and things like that, but Oh, cool. Good to know. Make sure you spell thought correctly, Johnny. Ooh, that's intense, Serenius. That's crazy. Yeah, good old South Kakalaki. Good stuff, good stuff. All right. Ugh. So the plan for today is to help with the total and net ionic equations worksheet. Weaver's made a connection to a random guy in... yeah. Sorry, I got links blocked. But I believe you. I'll look it up. Cashes, I can see that. Trinity, we're gonna go through a whole bunch of examples, so just hold off 1 second. We'll go through a whole bunch of examples. Yeah, Cooper, that's all I'm really gonna go through is just kind of help with the homework. Nice. Yeah. So if you haven't already pulled out the homework, make sure you pull out your homework. Yeah, tornadoes are intense. All right, let me pull up this. Okay, so as a reminder, this was the homework worksheet. Well, so some people like printed it off. Some people like printed off a copy of the worksheet. So if you print it off, or if you like wrote down like your answers somewhere, you got to take that out. Yeah. What? That's not profanity. Yeah, so I teach both high school level and the freshman undergraduate level Slayer. My college class just ended last night. So that was their semester just ended. So they have their finals coming this week. So yeah, Trinity, we can go through number 2. We're going to probably go through that one. So again, this was the worksheet. It's on Canvas. It's just a whole bunch of molecular total and net ionic equation. We went through number 1 during yesterday's stream. Or not yesterday's, Monday's stream. I was going to do probably 3 or 4 of the problems. Just to kind of help you guys through it, and then I'll walk you through how the submission file or how the submission quiz works on Canvas as well. So yeah. So like I said, we're gonna do like 4 or 5 of them. We'll kind of just see what problems you guys have. I know 8 and 9 are a little intense. We'll talk about those ones. But let's start simple. Let's start with number 2, and then we'll go from there. So if you've already got number 2 done, just follow along. Make sure that you've got the same things I do. Okay. So in number 2, the question says aluminum. Let me pull this a little closer. So it says aluminum. Right. So aluminum is going to be Al, solid. Nothing fancy about aluminum. It's not a diatomic element. Your finals got canceled. No way. They canceled finals. That's intense. I don't know if I would do that. So aluminum solid. So aluminum reacts, and then it says a solution of lead to nitrate. So PbNO3, right? Lead is Pb. Nitrate is NO3. We'll worry about all that when we get there. They did just announce yesterday that school is probably going to stay closed throughout the rest of the semester, or throughout the rest of the school year. So yeah, Drake's pointed out already, the fact that this is a 2+ means that we need 2 of the nitrates to balance it out. Right. Nitrate's -1, lead's a +2. If this is a +2 and this is a -1, we need 2 of them. The problem mentioned that it's a solution, so we know it's going to be aqueous for the phase. It will definitely be, Xander, the final will definitely be less intense than it would be if we were in school. So, all right. It says it forms solid lead. So that's lead totally by itself. And it forms a solution of. Okay. So, what kind of reaction is going on here in number 2? Good, Trinity. It's a single replacement. So if our lead is stuck by on its own, that means the aluminum is coming in to replace the lead. Oh, right, Serenity. So I forgot that you're in like a culinary school. So then the aluminum comes in and pairs with the nitrate. Okay. But we got to remember that the aluminum, if we look at a periodic table, right, remember aluminum is +3. Okay. Aluminum is here. And it's a +3, right? Silver, zinc, aluminum, we're +1, +2, and +3. And so if the aluminum's a +3, that means we technically need 3 of these guys to balance it out. Okay, so we've got all the formulas. So the aluminum comes in, replaces the lead. We get lead by itself, and we get aluminum. So the aluminum reacts with lead nitrate to make lead and aluminum nitrate. I think you're right on that, Enya. Let's double check this. Okay, so the problem is we've got the nitrates. So there's 2 nitrates over here and 3 nitrates over there. So the only way to get this to work out would be if we got the nitrates up to 6. So we're going to add a coefficient of a 3 here and a 2 there. And by doing that, we need a 2 here and a 3 there. So 2, 3, 3, 2. Yeah. Yeah. 2, 3, 3, 2. So, and yeah, I think you had your coefficients backwards there. So 2 aluminums, 3 lead nitrates, 3 leads, 2 aluminum nitrates. Okay, so before we get into this, right, I want to kind of remind you of a few things that we talked about on Monday. In order for the aluminum to replace the lead, what has to be true about the aluminum? Yeah, thanks, Lauren. It's got to be more reactive. Good, good. Everybody's spamming the chat. More reactive. Good. So if we actually look at the chart, aluminum is higher on the list, and so it is more reactive, right? And so if you look and verify, you can. The problem kind of told you it did. What we're going to be doing for next week's assignment is we're actually going to be... there's going to be less information given, and so you're going to really have to fully predict, what's going to happen and things like that. So that's where we're working towards. So I just wanted to point that out. All right. I did also wanted to show you guys a cool video of a single replacement reaction. I didn't get a chance to grab the elements and chemicals to do it, so I do have this quick video. So this is a... So what they've done here is they have a solution of silver nitrate. So they have silver ions in solution. So silver nitrate here, and then they have solid copper. The copper is going to replace the silver in the solution. And so what will happen is the silver comes back onto the copper. And so we're going to have solid silver forming on the wire. So they've done a time lapse here because it does take a little bit of time, but you'll start to see as the video goes, the silver actually forms onto the wire. So here we go. It's got some cool music too. So you see the silver crystals growing. So that's pure silver growing on the wire. So the copper ions are going into solution and the silver's coming out. You'll also notice the solution starts to get a slight blue tint. And so the blue tint is from the copper ions. So the copper ions have a blue color to them. So it's not. It's so hold on, Izzy. It's not that there's more silver than there was copper. The silver has a very low density. It's really fluffy, and so it kind of grows in like a fluffy chain. There's holes all through it. So the copper, if we were to pull the silver off, man, so many questions. If we were to pull the silver off, the copper wire would be thinner, right? So the copper goes into solution, so the wire itself gets thinner as the silver starts to go kind of on the outside. How's liquid change? Yeah, so the copper ions go into solution. Oh gosh, did he actually collect all the silver, Weaver? So the copper is replaced. The copper is replaced, Xander. It's not just encased, it's replaced. There's a swapping going on between the copper. Stonks. Okay. Yeah, so Drake, the silver does slightly block it, but there actually are like little tiny pores that the copper ions can still kind of escape through. If you look down at like a microscopic level, there are these little tunnels that the copper ions still can go out from. It's really cool. So, yeah. The copper is more reactive, Jonathan, because if we were to write the reaction, it's solid copper plus silver nitrate, and so the copper is replacing the silver. So the silver comes out of solution and is left on its own because it's less reactive as a metal. Okay. So like I said, I just wanted to show this. It was kind of a cool video that kind of illustrates what's actually going on in these problems. Same amount of... So yeah, so Enya, so what Weaver's saying is he's saying that more or less this teacher got the school to pay for the silver nitrate chemical, and then by doing the reaction, the teacher collected the silver. So really he's just stealing from the school. is what it turns out to be. Which is why it's kind of funny. No, you're good, Enya. No, you're good. The perfect crime. The perfect crime. Okay, so back to this problem, right? So we've got our balanced chemical equation. Yeah, no, I would never purify the silver and take it home. Some of the other schools I know, they actually will redissolve the silver back into concentrated nitric. Yeah, it's really soft. And it's also pretty impure. Well, like it's like it oxidizes really easy. You could collect it and melt it and reharden it, and you would get a little bit out of it. You wouldn't get very much. Stealing from Tiffany's. I don't even think you spelled Tiffany's correctly, Drake. Okay, so when we go from the molecular equation to the total ionic, our solids are going to stay as solids. So 2Al solid. No change there. Okay. The lead nitrate, on the other hand, is an ionic aqueous compound. We have a metal and a nonmetal, right? A positive and a negative, and so it's going to split. The way it's going to split is it's going to split into my lead ions, 3Pb2+, right? And then we got to remember with the nitrates, those subscripts come out in front, and so that makes 6 nitrate ions, right? So we have 2 aluminums, 3 leads, 6 nitrates, because again, this 2 comes in front when we multiply through. That produces, okay, the lead here, it's solid, it's going to stay the same. And the aluminum nitrate is going to break up in a very similar fashion to the lead nitrate. So it'll break apart into the aluminum ions and 6 nitrate ions. Okay. So this is our total ionic. When we go from total ionic to net ionic, so this is the total ionic equation. When we go from total to net, what do we do as we go from total to net? Yeah, we eliminate the spectators. So we get rid of the spectators. In this case, the only spectator is the nitrate ion. The aluminums are not spectators. Aluminum solid and aluminum 3+ are different. Lead 2+ and lead solid are different. But the nitrate aqueous, those are the same. And so then my final result is 2 aluminums plus 3 lead ions makes 3 leads and 2 aluminum ions. Okay, cool. So when we go to so this is the work that we're going to show for the problem. Could there be a situation where everything is a spectator? Yeah. So if everything was a spectator, we would technically say that there's no reaction. On your homework, there aren't any where everything is a spectator. There will only be 1 or 2 spectators per problem. But yeah, if you had a situation where everything was a spectator, we would say that there technically is no reaction. Aluminum is also a different phase. Yeah. So if phase changes, that's not the same. Okay. So if we go to... so a spectator, remember, Jonathan, a spectator is something that doesn't change in the reaction. It doesn't react. And so since it's not actually participating in the reaction, it's watching like a spectator watches a sport, you can cross it out. So a normal element's an ion. The different Izzy is the charge. And so the charge comes from the losing of the electrons. So Ellie, how did we know that aluminum was a 3+? That's because whenever aluminum is in a compound, aluminum always forms a 3+ because of its position on the periodic table. Okay. The reason that we knew lead, was a 2+ is because in the problem it tells us that lead is a 2+. Let me scroll down to it. So in the problem it says lead 2 nitrate, and so that lead 2 nitrate is how we know that the lead is a 2+. Okay. So let's talk about how we're going to turn this in on Canvas, right? So the first problem here says aluminum reacts with a solution of lead. So this is question 2a. So an ion is like a normal element, but it has a charge. Yes. Or technically it could be a polyatomic ion too, Izzy. So like nitrate is an ion. So yeah, position on the periodic table. Ion is like a normal element, but has a charge. Yep. Those are all ways to think about it. Okay, so we just wrote down the molecular equation. We said it was aluminum plus lead nitrate. Now we make sure we get 2 of the lead nitrates, right? And we said it made lead and aluminum nitrate. Make sure we get the right one. Aluminum nitrate. Yeah, it was posted yesterday afternoon. I posted it, Enya. Yep. So again, this is due tomorrow night at midnight. So if you've done it on paper, transferring it to Canvas is fast. And so it shouldn't take you very long. Okay, and then if we look, so that was 2a, so we wrote down the equation. 2b says, what are the coefficients? Enter your answer as a single 4-digit number, right? Our coefficients, if we go back to it, yeah, so our coefficients were 2, 3, 3, 2. Technically, couldn't you remove the 2, 3, 3, 2? Oh, so no, Lauren. And the reason why is slightly a more complex thing that we're not going to get into. But technically, a true balanced equation should have an even, the charges should be even on both sides. And so because we have a total of 6 positives on the left, we have to have a total of 6 negatives on the right. And so, yeah. So, no, you technically can't. An A for class is still going to be a 95.5, Hunter, but I'm going to still have extra credit on a bunch of things. So, if we go back to the Canvas, right? our answer, our coefficients were 2, 3, 3, 2. Okay. I should have added, oh, that's what I should have done. I should have added a coefficients on the total ionic equation. That would have been good, but whatever, it's not a big deal. Okay, then we go to the 2C. When writing a total ionic equation, what happens to each compound? So aluminum stays together, lead nitrate splits, solid lead stays together, and the solution of question mark, aka our aluminum nitrate, splits. Okay, then we go to 2D. Aluminum reacts with lead ion. Are there any spectator ions? We said that the nitrates were spectators. Okay, the aluminums weren't, the lead wasn't. That's wrong, right? So then we would say the nitrate ions, and that's how you do it on Chemist. The reason why, Jonathan, is because the original problem it wants you to predict what the products are, and so I didn't want to give it away in the part C of the prompt. So these are if we look, the 4 components of the reaction. Nitrate does love being a spectator. The 4 components of the reaction were aluminum, lead nitrate, lead, and aluminum nitrate. But the problem didn't tell you aluminum nitrate. You had to predict what this was based off of the single replacement. I think I have it set to 5 submissions, Lauren. So you can do it at least 5 times. So let me go back to this. So I do want to point out something though that's going to be different about this one than was the one we did 2 weeks ago. If you scroll down to the very bottom, there's a 15-point problem that says to upload an image of your work to prove that you've completed the assignment. And so you need to upload a picture that shows more or less this. It needs to have this shown for each problem. Now you can either print out the worksheet if you want. You can just do it on extra paper like I'm doing it. You could do it on whatever kind of scratch paper you can find. So either if you've printed out the worksheet, you can just fill it out. And then go from there. Yeah, so Xander, if you do not have this last picture, even though I have it as 15 points, I'm probably going to take off some points as well. So you can do as many pictures as you want, I think. So what you want to do, actually the best thing to do, if you guys don't know how to do it, the best way is to create a PDF using your phone. If you have an iPhone, it's actually pretty easy to create a PDF. Let me show you. So if you're in a new notes section, right? So Izzy, that's the thing, is if you're not confident on your answers, you don't have to worry about uploading it the first time. But when you do, so you don't have to upload it every time unless you are how do I say it? So you can upload it every time, yes. But if you only want to upload it once, you can just do it the very last time you do the assignment, because your last time you do it, or the highest score you get, is going to be what saves. No, you don't. On this worksheet, Hannah, you don't have to check if they're more reactive. On the worksheet we're going to do next week, you do. So that's kind of what's coming. We're building into that. But on this worksheet, the reaction, that you're going to assume they happen because they happen. Yeah, so you can do Google Docs, you do it that way, but it only lets you submit a single file, so you can't upload multiple files, I don't think. Yeah. So you can't upload multiple files. You can only upload one file. That's fine as well, Lauren. That's fine as well. I want to see that you guys are actually writing out the equations. I'm not gonna really study it in detail. Yeah. So Izzy. Yeah, so you want to make, you have to make some sort of a PDF though. You can either, so what you can do is you can like take a couple pictures and then put them all into a Word document. You can like, but you have to do it all as a single file. So in an iPhone, you can do it as a notes. In the notes, let me show you in the notes. If you do the, oh my gosh. There's this little menu. Whoop, these little things. If you click the camera and you say scan document, if you do scan document, it'll let you take a picture of multiple pages, and then you can send that to your email and then upload it that way. So that's one way to do it. There's a bunch of ways to do it. So make sure that you don't try to, you can't submit multiple files. You can only submit one file. So make sure the file you're submitting has all of your pictures. Yeah, putting them into Google Docs is fine. Yeah, just uploading them and putting them into Google Doc and then uploading the Google Doc, that's fine too. So as long as your single file has all of your work in it, you'll be good. You'll get half credit, Drake. No, take a picture of both sides. So you just want pictures in one file of every problem fully written out. Yes, ma'am, Tiara. That is correct. It needs to have every problem on it in order to get full credit. If you filled it in, Zach, don't submit the blank Word doc. But if you have it filled in, yeah, that's fine. Okay. Let's do another problem or two. So which one, those of you that have, yeah, then that's fine, Zach. H2O is liquid, Hunter. H2O is liquid. Parker says number 10, but number 10 is not the hardest problem. Number 8 or 9 are the hardest problems. And you knows, let's do 8. So if we scroll back up to problem number 8. Okay, so problem number 8 says solid manganese 4 oxide is acted upon by hydrochloric acid, making chlorine gas, water, and a solution of manganese 2 chloride. So we have 5 things in this reaction, right? So let's blank this out and let's work on it. So number 3. Okay, so it says manganese 4 oxide. So that would be manganese, Mn, oxide is O. In this problem, they're telling us the Roman numeral 4 tells us the manganese is a +4. We know from the periodic table that oxygen, right, oxygen up here, oxygen is a -2. And so if we have a +4 and a -2, we know that the formula needs 2 of these oxygens. So it's going to be MnO2. Now the problem tells me that, excuse me, the problem tells me this is solid. So I need to make sure to remember that this MnO2 is solid, not aqueous. Right, it's solid. So solid manganese oxide is acted upon or reacts with hydrochloric acid. Now, hydrochloric acid is just HCl. And yet, acids are aqueous. Aqueous. So hydroic comes from chloride. Yeah, I got the Rona. Hydrochloric comes from chloride. Chloride is just chlorine. And so HCl is hydrochloric acid. So all acids on this worksheet are aqueous. So just as kind of a heads up on that. So MnO2 plus HCl. Okay. The problem says it produces chlorine gas. Now we got to remember chlorine is one of our diatomics. It's one of our honeyfickle burrs. So when we have chlorine gas, chlorine by itself, we need to indicate that it's Cl2. Okay, it makes chlorine gas, water, which is a liquid, right? As Hunter asked earlier, water's a liquid. And then it says a solution of manganese 2 chloride. So the manganese, it's changing its charge. It was manganese 4 over here, but on the products, it's manganese 2. So it's something's happening with its electrons. So if we have manganese 2 chloride, chloride is just plain old chlorine. Chloride, it's in the halogens, right? Right there. And so it has a charge of -1. So if the manganese has a charge of +2 and the chlorine has a charge of -1, we again just need 2 of these guys. And that's going to be aqueous. Okay, so manganese 4 oxide is acted upon by hydrochloric acid to produce chlorine gas, water, and manganese 2 chloride. Okay, so those are all our chemical formulas. Now at this point we need to balance the equation. So 1 manganese, 2 oxygens, 1 oxygen, so let's put a 2 there. 1 hydrogen, 4 hydrogens, so we need a 4. 4 chlorines, 1, 2, 3, 4 chlorines. There we go. So our coefficients are 1, 4, 1, 2, 1. Yeah, and you just got it. 1, 4, 1, 2, 1. Okay, cool. So we have our balanced chemical equation, right? Balanced molecular equation. So at this point, we go from our molecular to our total ionic. And so we're going to be splitting aqueous ionic and aqueous strong acids. Now that's important because this first chemical is an ionic chemical, but it's solid. And because it's ionic and solid, we do not split it. Okay. There's a couple other problems where if a solid is produced, it's called a precipitate. So that's going to kind of help you on those ones where if it says it produces a precipitate of something, precipitate means solid, or precipitate means solid. So our MnO2 solid, right, it's going to stay together because it is a solid. Even though it's ionic, it's a solid, so it doesn't split. Now when it comes to acids, we have to remember if it's strong or weak. We had 7 strong acids: hydrochloric, hydrobromic, hydroiodic, chloric, perchloric, nitric, and sulfuric. So hydrochloric is a strong acid, and so it should split. Now it's going to split into 4H plus and 4Cl minus. Okay. Chlorine gas is a gas, so it's going to stay together. Water's a liquid, so it's going to stay together. MnCl2, aqueous, ionic, metal and a nonmetal, so it's going to split. Not necessarily, Jonathan. If you need help with the phases, I actually, on the canvas, I've written in the phases for you. So that'll maybe kind of help guide you if you feel lost on figuring out what the phases are. So on this one, solid, aqueous, gas, liquid, aqueous. So that'll kind of help you out if you need a little help with the state. All right, and so our manganese chloride is going to split into Mn2 plus aqueous plus 2 Cl minus aqueous. All right. Okay, so Inya's already on to the next question I was about to ask. The spectators are 2 chlorines from each side, not all 4 chlorines from the first side. No, you're totally good. I'm glad. This is what you should be doing. This is what I wish everyone was doing, is that everyone was, really engaged and working on it and trying to figure out these answers. Do not ever apologize for being good. Okay, so the 4 chlorides here and the 2 chlorides there can cancel, right? So we get MnO2, 4H plus. So 2 of our chloride ions go away. Okay. All right, so if we look, right, our 4 chlorides here and our 2 chlorides here, it turns out with the 4 chlorine atoms, 2 of them turn into the chlorine gas, and 2 of them go into this compound. The 2 that go into the compound aren't actually doing anything, and that's why they get eliminated as spectators. The 2 that turn into the chlorine gas are reacting technically. And so this is one of those cool cases where some of your ions are spectators and some of them are actually involved in the reaction. And so that's why we eliminate 2 of the chloride. So we would still consider chloride to be a spectator. So if we take this and go over to the canvas and try to put it into the canvas, we'll see. So are these going to have only one? So icy snow, I don't know who that is. There are some that have more than one spectator. I think there's maybe 2 or 3 that have 2 spectators, but a majority of them just have 1 spectator. All right. Okay, so let's jump over to the canvas. Yeah, 2 spectators. So if we jump over to the canvas, right, the molecular equation, we said it was MnO2, right? Then we said it was HCl. Then we said it was Cl2. No, number 7 should have a spectator. All of them have at least 1 spectator. All of them have at least 1 spectator. So let's see, MnO2, HCl, Cl2. We said this one was water. And then we said this one was MnCl2. Okay. Our coefficients were 1, 4, 1, 2, 1. Yeah, the nitrate on number 7 is a spectator, Sadie. Good call. And then let's see. We said manganese 4 oxide stays together because it was a solid. Hydrochloric acid splits because it's a strong acid. Chlorine stays together because it's a gas. Water stays together because it's a liquid. And manganese 2 chloride splits because it is ionic. And then we said that the chloride ions were spectators. Is 12, 11, or Alaska? What? Okay. So we've got time to do one more problem. Which ones do you guys want to do? Which one? Is there like a trick to figure out when it says and what aqueous? Yeah, so Lauren, those are oh gosh, everyone's number 9. Yeah, we'll do number 9. So everyone said, so Lauren, on the reactions, they're all going to be, if you haven't figured this out yet, all of the reactions on the worksheet are, at least most of them besides 8 and 9, are single or double replacement reactions. And so if you look, not this one, but this was a single replacement. And so if it asks you to predict and what aqueous, it's usually you have to look and try to figure out, is it a single replacement or a double replacement? And so that'll help you predict what the product is. So yeah. Okay. Number 9. I'll go to a new page for number 9. All right, number 9 says, if we look at it, right? So number 9 says hydrobromic acid reacts with a solution of potassium bromite to make bromine, water, and a solution of potassium bromide. Okay, so let's see if we can work through it. So number 9, hydrobromic acid. So hydrobromic acid is the same as hydrochloric acid, just with HBr instead of HCl. So hydrobromic acid, HBr. Okay. Ide is from the element, Drake. Ide is from an element. So hydrobromic acid, I need some focus. Hydrobromic acid reacts with a solution of potassium bromite. So potassium bromite. Now we got to be careful. Bromate is BrO3. Bromite is BrO2. Lauren, on this worksheet, all acids are aqueous. Yes. And for anything we're going to be doing in this class, if I call something an acid, it's aqueous. It's implied it's aqueous. All right, so potassium bromite, right? Told us it was a solution, so also aqueous. And then it says it produces bromine. Bromine is diatomic. Okay. They tell us that the bromine's aqueous, which is kind of cool. Bromine does dissolve a very small amount in water. So bromine, aqueous, water, H2O liquid, and potassium bromide. Oh, I forgot to mention charges on this last one. So potassium's a +1 because it's in the first column on the periodic table. Bromite is a -1 because it's the same as bromide or bromine. So +1, -1 here. Same thing over here, +1, -1. Okay. So let's see if we can figure this out. So we've got a problem when it comes to balancing this equation. The problem when it comes to balancing this equation is that there are bromines everywhere, right? So we have bromines all over the place. And so I'm going to hold off on the bromines until the end. Okay, so let's hold off on the bromines. So if we hold off on the bromines, and yet I think you might have BrO3 instead of BrO2. Double check that because it needs to be BrO2. Because if it's BrO2, that means there's 2 oxygens here, which means we need a 2 in front of the water there. Okay. Now by doing that, we now have 4 hydrogens. So I'm going to do 4 hydrogens. Okay. So at this point, let's look at the potassiums, 1 of each. Okay, so we're good. So we've got oxygen balanced, we've got hydrogen balanced. Now we got to figure out the bromines. So with the bromines, I have 5 bromines, and I have 2. But I don't want to change this because that would screw up this, which would screw up everything else. So if let's see, I have 4, 5. If I put a 2 here, right, that makes 4 plus 1 is 5. And so our coefficient should be 4, 1, 2, 2, 1, right? So 4, 1, 2, 2, 1. Because 4 hydrogens, 4 hydrogens, 4, 5 bromines, 4, 5 bromines, 1 potassium, 1 potassium, 2 oxygens, 2 oxygens. Okay, so little tricky on the balancing. The balancing on this one's pretty hard. Hopefully you were able to get that, or hopefully you're able to follow along. Okay, let's go. Let's split stuff. Okay, so hydrobromic acid, strong acid. So it's going to split into 4H plus aqueous, 4Br minus aqueous. Potassium bromate is going to split its aqueous ionic into potassium and the bromite. Bromine, right? It's going to stay together because it is a molecule, or it's a non-metal, right? It's molecular. Water is going to stay together because it's water. It's a liquid. Potassium bromide, again, aqueous ionic, so it's going to split. Okay. No, because even though it's aqueous, Cooper, it's not ionic and it's not a strong acid. So it's not ionic and not strong acid, so it stays together, right? It's only aqueous ionic and aqueous strong acids that split. Okay, so this stays as 2Br2. Yep. Okay, so let's look here. We've got any spectators? We got a lot of stuff. Any spectators? Yeah, so the potassium for sure, right? Everybody sees the potassium. Potassium for sure. Enya's also pointing out that one of the bromines goes away because this guy over here, this bromide ion, can technically cancel out with one of these bromide ions. These bromines don't cancel, right? But one of these will. And so our end result is 4H plus 3Br minus plus BrO2 minus makes 2Br2s, 2 waters, and that's it. Cool. So if we go back to the canvas, here, I'll leave this up for a second if you guys are jotting this down or grabbing a picture of it. I'm glad, Enya. That's why we're doing this. That's why I'm spending Wednesday helping you on the homework. So again, make sure that you get this submitted by tomorrow night at midnight. I'll be available this afternoon for questions. I'll be in the Discord, or I'll answer emails and stuff like that. I'll answer emails and questions tomorrow during the day. So if you have any more questions, feel free to send them my way. I do have a meeting today with the principal at noonish. I have all the department chairs and the principal get together and kind of talk about how things are going this afternoon. But that shouldn't take too long. Drake apparently is better than everybody and says this was easy, so we'll see. Let's go back. So number 9. So good question, Icy. You move the subscript to the front when you're splitting, okay? But not if it's part of a polyatomic ion. So let's actually, we can use this as a good example of that. So when we split potassium bromite, we didn't move the 2 in front because bromite is defined as BrO2. On the previous question, or say on this one, right, when we split this one, this 2 comes in front because it's not part of the nitrate. Same thing on this MnCl2, the 2 comes in front because it's not part of a polyatomic ion. So only the polyatomic ions, the numbers stay below. So anytime you split something, you're going to bring those subscripts in front unless it's part of the polyatomic ion. Lauren, a good question about phosphoric acid. So phosphoric acid comes from phosphate. And so phosphate is PO43 minus. So phosphoric acid is H3PO4. Okay. Okay, so back to submitting this one on the canvas. So number 9, hydrobromic acid, HBr, reacts with potassium bromite, KBrO2, to make bromine, which we remember is diatomic, so Br2, water, H2O, and potassium bromide, KBr. We said the coefficients were 4, 1, 2, 2, 4, 1, 2, 2, 1. Okay. And then we said hydrobromic acid splits because it's a strong acid. Potassium bromide splits because it's aqueous ionic. Bromine stayed together because it was a molecule. Water stays together because it's a liquid. And the potassium bromide splits. In terms of spectators, this one actually had two spectators, the bromide ions and the potassium ions. Not the bromite ions, but the bromide and the potassium. Those were both spectators. And that's how you do it. Okay, so hopefully this gave you enough of a kickstart. If you want to keep working on this, feel free. We are going to kind of end the stream now. Make sure that you get this done by tomorrow night. I'm going to be updating grades and putting this in on probably Friday. So recap for Jonathan. What changes in each equation? Like what changes from going from molecular? Oh, okay, yeah. So when we write the molecular equation, we write all the chemicals, all the formulas, coefficients, everything. When we go from molecular to total ionic, two things happen. You split aqueous ionic and you split aqueous strong acids. Okay? So when we go from molecular to total ionic, you should be splitting aqueous ionic and aqueous strong acids. When you go from total ionic to net ionic, you're going to be eliminating spectator ions. That means you're going to be crossing out those ions that don't change. You'll have like a Br minus on one side and a Br minus on the other, or a K plus on one side and a K plus on the other. Those are our spectator ions. And so as we go from total ionic to net ionic, we eliminate those and write the equations with the spectators removed. So hopefully that's good, Jonathan. Split aqueous ionic and aqueous strong acids, remove spectators. Okay. Yeah, so that'll be it for today. Make sure you get this in. We're going to do some new stuff on Friday. We'll have a new assignment for next week. Yeah, if you have questions on this, make sure to drop into the Discord this afternoon or tomorrow, or to shoot me emails, messages on Canvas. I'll be checking everything and answering everything as best I can. But that is all for today. Hopefully you guys have a good luck. Yeah, have a great day. Bye, Naya. Bye, everybody.